coming here. As Peter mentioned, I will be talking about how we heard microservices within my team. So a little bit about my team, just to give you some heads up. So we are IT dev team. We are about 12 developers, and we operate now around 15, maybe 20 microservices. So we have more microservices than developers at this point. And we are located on 3 continents, which gives certain challenges, as you can imagine. And the vision of my team, what we actually are meant to do, is to provide great customer experience for our external customers who come to our support center, but also to about 300 support agents who use our services every day. And in order to do that, we interconnect many services. Sometimes it feels like, you know, the old switchbox where you have talking to billing system, to get the licenses from which customers have, to actually render them in the front end, so customers can choose a license that they need support with. And also we have a bunch of business rules based on availability of certain teams or business priorities for certain types of issues when we need to know, is this customer entitled for premier support or are they a priority customer? So there are a lot of things that we need to know. And when I look back, I think like 4 years ago, we started pretty early with microservices. So it was much different, and I'm going to walk you through how things changed and how it influenced us and how we run services. So in the old days, we still were building microservices in AWS. So nothing changed from that perspective, but we were using EC2 instances, sometimes Elastic Beanstalk, deployed WAR archives there, manually created SQS queues or Redis instances we needed to. And our logging was whatever was in AWS back then, which is just CloudTrail. And if you have used it, it's OK. But if you need to do some searches through multiple services in their CloudTrails, it's not really that useful. And last thing was monitoring. We were using CloudWatch, but we didn't publish any custom metrics. So we kind of were dependent on what's available in CloudWatch for us automatically. And it worked. When we were about 4 developers, we were able to operate these services pretty easily until the incidents happened. So just imagine the incident happened and you're like in the middle of it. Really like, this is a satellite photo from, I think, Swindon in UK. Magical roundabout, you are people asking for help, people saying this doesn't work. So just to give you a glimpse, 3 years ago even, we had a hip chat room called Outages, and anyone from Atlassian just came there and said, oh, this doesn't work. And teams like my team and other teams around the globe, they were supposed to monitor this room for messages and saying, oh, is this our service? Do we need to do something? So it was very organic, and because we are dependent on so many other services, what happened was that sometimes we were not the root cause, but other service was having an issue, and we were struggling to find out who is the one who we should talk to, should we page someone? It was kind of chaotic. And I think the problem was we were treating our services a little bit like pets. And the analogy goes, you know, we went to the AWS EC2 instance, we SSH to it, we did some changes, maybe we changed some permissions on SQS. It was kind of manual process. You kind of treated that service very specifically. And we knew that this cannot be done forever. Like, we have to scale up work. And not only us as our team, but the whole team, all teams around Atlassian. So one major change, I would say, from back then to today, is that we now have a unified platform as a service. It's still built on top of AWS, but any team can just use it, and it tries to promote the best behaviors or best practices. And what those are, that's what I'm going to talk about next. It's this. In general, cattle, not pets. Maybe if you're not familiar with the alternative, we were treating our services previously as pets. Now, for example, we are not even able to SSH to any of the EC2 instances that run on the platform that we have. You have to declare everything in your descriptor, which is kind of like a YAML file. It's actually a YAML file with description like, I'm going to use a database, I'm going to use a Redis. But you will not get back, this is your instance, this is the IP. So we actually automatically provision the EC2 instances and containers there, resources, You don't necessarily need to even know that there is policies attached to all of these. It's done transparently. It's built on top of Docker Compose, so you can use pretty much any Docker containers if you want to. It's very powerful because we have a CLI that allows us to deploy from Bamboo or Bitbucket pipelines. And we can reuse a lot of components. And it wasn't that obvious in the beginning, but because of Docker Compose, we can have multiple so-called sidecars running next to our service, which can be, for example, for log aggregations like Splunk, or for statsd daemon for metrics. We even have service-to-service protocol that we now have a sidecar, so you don't have to build it yourself. You can deploy and build on top of what other teams did. And lastly, because it's unified, you can enforce the standards and best practices. And in our case, we started with few fields, like every service needs to have an owner, needs to have a business group that's going to be charged for the costs. It needs to have a Opsgenie team that's going to be paid when the service doesn't work. And all of this is enforced before deployment to production, at least, so you're kind of sure that you don't deploy something that nobody knows about. And the great thing about this is that despite that we build this in-house, there are a lot of alternatives for these problems that many of you might have. So for provisioning, I believe there's OpenShift, there is Flynn, there are other services you can use. I think there's a pathfinder.org where you can compare different offerings. And I'm going to go back to the monitoring at some point, but for the best practices, I've used PVO. It's a small open source project, allows you to do some sort of service inventory, and you can add your own checks there. So everything else is Docker, which is nice. The next thing I want to address is the incident handling. As you've seen, it was chaotic, it was problematic, and now we tripled the size of the team. We have created many more services, and we need to be able to handle that in a unified way. So I'm going to walk you through the steps, how they work today. And the first one is the detection of the problem. In the past, it was very organic, and now we just automate everything. So as I mentioned, we have a sidecar for statsd collection, so we send our metrics, custom metrics from each service, plus generic metrics like CPU usage, hard drive space, and stuff like that. We send them to SignalFx. We use Datadog, sorry. You can use anything that actually is offering that. But it's very powerful because you can prevent some of the problems before they actually become problems. If we don't have automatic detection for some stuff, there is an end-on cord. End-on cord is a Toyota manufacturing term where you kind of have an emergency brake. Something breaks, you stop it. We kind of had it in the hip chat room, but now we have something much better, which is Jira. Dedicated Jira instance where anyone can come in and raise a ticket. We call it hot ticket, incident ticket. And the only three things that are required there is the severity of the problem, the services affected, and a little bit of description. And the magic happens afterwards. So we automatically escalate the ticket or the problem to the owning team. And that's why it's very good to have the standards, because you can detect who is the owner of the service by just looking at the service descriptor. And in order to say, should we wake someone up or should it wait till tomorrow, we define service tiers. So some services that are important, of course, you need to wake people up. Some are maybe less important that the problem can wait. And lastly, you need to communicate. And there are many tools you can use to communicate. A little bit of the communication is shown here. So after the moment of detection, there's this hot ticket raised, and Opsgenie is automatically paging people who are on call for this service. Once that page is accepted, somebody starts investigating, and what we actually have an automation for, very simple, I think it's built by third-party plugins, is that you can open a Slack channel just right off the ticket view. You can update a status page. You can open a Zoom video chat if you need to have more people in it. So it's very collaborative if you need to. And the last part is, well, resolving, which I'm going to go back to later, but this is pretty much straightforward communication, hopefully, even for the new members. So in order to start resolving a ticket, you know to know what the problem is, right? And we have a specific step that is checking for the global changes. And why that is important for us is that 23% of all the incidents from last 2.5 years that were in the system were caused by a change, either internal or external, but change is something that you can hopefully change back, right? So how do we find these changes easily? Well, we're developers, so we write software for it. This is a Splunk dashboard that's produced by this microservice. We call it Change Gateway. It detects all changes within the whole Atlassian, which can be deployments, which can be feature flag switches, which Peter was talking about earlier, even things like Jira tickets when you move to a certain status. It's very simple to actually write, and the dashboard is here showing one very specific service, but it can show a wildcard of service. You can see all services starting with Jira. What has changed there? So once you identify that, well, roll back, hopefully, turn the flag off, and in some cases, hotfix, which still happens. But that's kind of the way we're thinking now. This is a straightforward process. Once the incident is resolved, we usually a couple of days later, we come to a post-incident review, which is kind of industry standard. Everybody hopefully is doing it. If not, there's a lot of value in it. We have a small template we use. We try to ask the 5 whys. Why do we detect it? How can we prevent it in the future? And anything that comes of this PIR, post-incident review, it's injected in the current sprint, mostly, as a high priority item. You don't want to have the incident happen again, so resolve it. And this is pretty much what every new hire is, in our team at least, is getting trained on. You need to be able to be on call. And one special sauce we have is not only looking at every individual incident, we do a weekly tech ops meeting. This is something we are doing, and we see value in it, so let me show you what it is. It's a meeting with the whole team. We go through all our services, so we don't focus on a specific one. We look at things like alerts, low priority alerts. Were they raised? If not, why not? If they were raised and they don't provide any value, maybe it's a noise, maybe we should reduce them. Next thing is check the KPIs. Every service has throughput, latency, a bunch of things defined, and we can see is the service operating as it should. So we have, let's say, 15 services. We try to go them really quickly, but you can do it once you're trained, and you can do it. And last thing is the code health. We check, did the test coverage get lower? Well, if so, is it a problem? Are the technical debt tickets raised for a specific service? We try to see if there is anything we can improve, like a preventive care for the service. So this is a lot of things we have changed since 3 years ago, 4 years ago. What do you think? Did it help? I was going through all these tickets we have, and I was going like, maybe it's going to be a good number that I can show you. It feels better. It's not a number, it's a feeling. Now when I go on call, I still don't really like being woken up, but it's very, very kind of focused. You know what to do, and you know that hopefully nobody else from your team will ever have to deal with the same problem again. And why I couldn't find the number is, unfortunately, this process that I'm showing here has been evolving in the years, so we don't have all the numbers on that. If you have questions about it, we can talk about it later. Just trust me on this. What's next for us is there are a few things that I still think we need to address. And the first one is we still have knowledge silos, especially because we have more services than team members. I want to know how many people know about this service. If it's only one, if that person gets sick or is on vacation, it's a problem. So we want to do it automatically, generate some sort of matrix and see where do we have knowledge gaps. The next one is the service costs. So every service comes with costs, operating it, not only running it, but like being on call for it. How much does it cost? How much is the price of a feature? That's very difficult to quantify, but our stakeholders would really like to know that. And lastly, our runbooks. We do have runbooks, but can they be executed by other team? Can they be wargamed by other teams so they can take over our on-call during their office hours? Maybe we don't have to be woken up at all in the night. That would be great. So if you want to bring something home, and this is something that I think is the core of what has changed for us and how it affected us, is these 4 things. Use a platform. Try to align with it. Use the guiding principle. Don't go and create something that is only specific for your team. B, use commonalities. Try to aggregate your logs and metrics in a single place. We use Splunk, but you can use Elk and Kibana. Our metrics go to SignalFx. You can use whatever works for you. Try to have it in one place, because then all the teams will profit from that. Runbooks and all these standards that we are enforcing, make sure that you maybe it's going to be just 2 fields that you want to know about each service, but it's going to be helpful in the future if you have to deal with GDPR and other things. You can enforce that as well. And learn. Try to learn from incidents. Try to learn from your failures of your service, or even things that should have been incident never were. And this is basically what worked for us. We are not there yet, but we are hoping that this is something that you can try at your own team, maybe in your whole company, and see if it works for you. Thank you.